Okay, so I am working on this string anagrams problem. I'm doing something new where in my previous videos I had looked at the problem before recording, but I had just pulled this up. I just pulled it up on the code and I haven't read through the problem all the way. And I will walk through my thought process as I'm reading the problem and going through what I might do, my ideas. So yeah, I just confirmed that these two are the same problems. Ignore this one and ignore this. Okay, so given two strings. Okay, so first off, whenever I think of anagrams, I think of I think of either an array, some sort of guarantee frequency map that maps the number of letters, or each letter to the number of occurrences in the letter, and the anagram and the original word will have the same letters and the same frequency of the characters. So that's what I'll be basing my solution off of. I'm guessing. Okay, so let's walk through an example input. And maybe what I might do. Okay. So C, B, A. Then this is our anagram to match against. So presumably we'd have an array with values of A, the value at A, the value at B, the value at C is equal to just 1. So once this will be our array that we're comparing against. Since these 3 characters are the only ones that matter, we'll just be looking at these for the purposes of simplicity. So start with C, increment by 1. Start with B. Start with A. And because these match, these are the same, we append to our result 0, the start of our sliding window. Then we go here, we see that E is no longer part of our anagram. This character does not exist in this character set. So we have a new sliding window starting from here. And do we even? I think so, yeah. So once we encounter B, then we start building towards this again, but I don't know if we should do anything with it. I don't think so. So we'll just keep that in mind for our solution. Encounter A. We encounter B. B is in our solution, however, the frequency at this point will be 2. Therefore, I haven't really been adjusting this as we've been working, but it would look like this right now. 1, 2, and then we see that this is greater than the number of b's that we are allowed in our input. So we change our sliding window such that it's still a possible valid sliding window. Then we get to here, we see the same thing. This becomes a 2, but that can't be possible with this input, so we adjust our sliding window to only include these 3 values. Okay, once again, BAC. Now we have another potential candidate. Well, we do have a candidate. These all match. So 1, 2, 0, 1, 2, 3, 4, 5, 6. At index 6, we have our result. Then we continue. We see a new character that is not in our result set. So the sliding window becomes just this character again, which is wrong, but yeah. Okay. So let's go and code up a solution. I've got to start the timer. Just add 6 minutes to whatever we were doing. Okay, so L is equal to 0. Let's see. First off, if length of P is greater than length of S, then we return nothing, I'm guessing. Yeah. L is equal to 0. We want anagram is equal to 0 times 26, which will be correct because yeah, we only have lowercase English filters, so there will only be 26 possible combinations. I might include anagram. A car set is equal to set P. I might just be including this so it's easy to see whether or not a character exists in our anagram. Yeah, this is just for sanity checking, I think. We don't necessarily need this, but it might be helpful. Okay. And then we want R in range length of S. Now we start iterating through S. Oh, actually, we also want our result to be. Then we also want to return this. Okay, just thinking right now. Cur letters is equal to 0 times 26. Oh, I need to populate the anagram array. Okay, so 4C in anagram. 4C in P. Ord A anagram. Ord. Okay, so what this does is it basically converts a character to, I'm not sure if it's an ASCII value. but either ASCII or Unicode, and then it subtracts it from the ASCII or Unicode from A, which gives us A should be equal to 0, P should be equal to 1, C should be equal to 2, Z should be equal to 25. Okay. Still thinking. I changed this name because I'm planning on using current letter here, and I don't want those two to get confused. So, yeah, equals SR. Okay, I'm thinking still. I'd solved the prior problem, and within the prior problem I kept track of the number of characters that were in P total, but I could just do that with the length of P. So think about more of what I need to do. So if this character, I think we can break it down into two cases, yeah. So if this character exists in the anagram, and if this character does not exist. If it does not exist, then what do we want to do? We want to reset our sliding window and our substring. Then continue. You need to make sure this doesn't cause any errors, because I don't want to accidentally include, like, say our string is, we counter an E right here. I don't want our reset substring to also include this E. Although we could, because we're not really looking at, actually yes we are. Okay, so need to set L to be 1 ahead of the current R value. So if you encounter this E, for example, we would be right here at B. Our L will be at B, and then it starts over again. Okay, so then if this character exists in the anagram, we need to make sure the count of our current character doesn't exceed the number in the anagram. This is I'm just making sure that for example, like in this case BAB, we have 2 in our current substring, but only 1 in the anagram. If that's the case, you want to decrement such that we only get this. Okay, so I think now we can start coding for sure. So if cur letter in car set letter, okay, substring a this is resetting our substring. One other problem I'm thinking of is how do we make sure that these two are equal? And my idea was, if we can guarantee that the number of elements in our substring are equal, so our window size is equal to the length of p, and we are guaranteed that every element in the substring is either equal to the number of occurrences in the anagram, which it has to be, then they're equal. So I'll also keep a count. So count plus okay. So while the count, or while the substring ord cur ord, this is going to be a long ord. What am I doing? Okay, anagram ord cur minus ord a. So I'm working with this right now. If it does exceed the number in the anagram, then we need to start decrementing the values at the left pointer. So left val, left car is equal to SL. If SL in car set, then our count is equals to 1. Here we need to add, by the way. So, oh wait, no, we did add. Okay, minus equal 1. Substring ord left car minus forward of A minus equals 1. L plus equals 1. R plus 1. Oh, I also need to reset the count here. So here we have, it's just bounds checking to make sure that we don't exceed the number of characters in our anagram for that given character. So if count is equal to length of P res dot append L. I'm not incrementing count anywhere, am I? So count plus equals 1. There we go. Does this work? Yeah, great, first try. Okay. So this is a, let's see, what's our space and time complexity? So our space is, it depends what you count this as, because P has at most 26 characters, so this is bounded by O of 26. Same with the anagram substring, these are also bound by O of 26. Every operation in here is going to be constant time. We iterate through the array once, but we potentially visit every value twice, but at most twice because of our left citing window. So I'm guessing, no, I know this is a O of n solution, but time complexity is debatable. I'm going to say it's O of 1, but you could say it's O of n, or O of p, I guess, because it's based off the size of our character set. Or it depends on our res too, because since we're storing the result, for example, let's say our result, or this was, P was the character A, and S was just 100 A's put together. The length of result would be 100. So if you count result, then it's a O of n potentially solution based off the length of our string here. But otherwise, I'm going to say it's O of 1.